Welcome everyone to the Watchlist, Australia's newest investor webinar series for ASX listed companies to pitch to real investors and be added to their watch lists. For companies, getting on your watch list is a big deal. It means they are being watched and have the chance to have you invest in them and follow their journey. We've regularly asked you who is on your watch list and who do you want to see present. You ask, we deliver. So today we bring you two presentations from companies repeatedly been asked to be on this webinar series. The companies presenting today are Altech Batteries, ASX code ATC, and Wildcat Resources, ASX code WC8. Each company will present, then management will be on hand to answer questions you have. So make sure while the presentations are on, you are looking and thinking about the questions you want to ask and submit them using the Q&A button at the bottom of the screen. Okay, let's get started. Our first presenter is Iggy, Managing Director of Altech Batteries. Altech Batteries is commercializing a 100 megawatt an hour solid state sodium chloride battery production facility and is also at the cutting edge of developing battery materials for a lithium ion battery future by successfully incorporating silicon in graphite anodes to produce higher energy density batteries. Iggy, over to you.
Well, thank you for having me, David. So most people will be wondering, what is the future of grid storage batteries? Well, before I start that, I want to talk about where the lithium-ion batteries are heading. They're heading to solid-state technology, and I'm sure you've heard of solid-state technology. I just want to explain what that is because a lot of people don't understand it. So in a normal lithium-ion battery, you've got a cathode and the anode, and there's a liquid electrolyte in between that, which has got lithium, but it's actually very flammable. What the industry is heading to is solid-state technology, where they're removing the liquid electrolyte and they're replacing it with a ceramic piece. And the ceramic is a solid state, which allows the lithium to go back and forth without using that liquid electrolyte. So some of the challenges of the lithium-ion battery is obviously fire. So next, well, there are fire and explosion issues. A lot of people don't realize that lithium-ion batteries only operate in a very narrow temperature range, down 15 degrees to 35 degrees. In fact, when you have your lithium-ion battery in the very cold, your battery slows down to about 70%. Also, we understand there's a limited life of these batteries because every time you charge and discharge a battery, lithium ions degrade. So generally 8 to 10 years in the bigger type batteries. The other concern is critical metals. There are price rises in critical metals in these batteries, and that is also a concern. So let's talk a bit about that. Lithium price has risen fivefold in the last 2 years, and that's causing some concern to the lithium battery sector. Cobalt supply, which is a key ingredient to some of these batteries, come from the DRC, and there's some ethical concerns about child labor issues and so on. 90% of graphite comes from China, so the industry is concerned about a geopolitical risk. Copper is an issue. There is a copper crunch coming. There is a study that shows there's not enough copper mines being built or developed to even meet the EV demand, let alone the grid storage demand, and obviously also materials like manganese. So the next slide. So is there a battery that is actually fireproof, operates at a large temperature range, maybe beyond 15-year life, that doesn't contain any lithium, doesn't contain any cobalt, doesn't contain any graphite, copper, or even manganese? Is there such a battery that's possible? Well, introducing you to the Serenergy battery. Essentially, this is a sodium chloride battery or salt battery with nickel metal powder. So that's what they look like. The technology was developed by the Fraunhofer Institute in Germany. They spent nearly 35 million euros in development over 8 years. And we have a joint venture to develop this technology. So It is actually a sodium chloride battery and solid state. It doesn't have that liquid electrolyte. So it uses a ceramic piece. So therefore it's fireproof because there's no volatile, flammable electrolyte in the battery. The temperature range it operates down to -40 degrees and up to 60 degrees. So you can plop this battery in the snow or in the desert, and it'll operate without any cooling fans and so on. Because we use sodium, sodium is a very reactive material, like lithium. It doesn't degrade every time you charge and discharge the battery. So the life of the battery should be beyond 15 years. We don't use any lithium, as I mentioned. We use sodium chloride. We don't have any copper in the chemistry, so there's no copper requirements, cobalt requirements. And there is also no anode of the battery. It's actually a self-forming anode, so we don't have any graphite or copper. So let me show you the technology and how this battery operates. So essentially you have a ceramic tube, and in the ceramic tube, there is a positive probe. We fill the ceramic tube with sodium chloride and aluminium powder, and there is a medium of sodium alumina medium in it. The ceramic tube, as you can see in the picture there, would sit in a metal canister, which acts as the negative part of the battery. So you've got the positive probe in the middle. The cylinder is the negative part. As you can see a picture here of the ceramic fitting into this. This battery itself, the way it operates, when you charge the battery, the sodium ions migrate through the ceramic sector and builds an anode. So it's a sodium anode that's being formed. And when you discharge the battery, so the nickel's there actually to grab the chloride and allow the sodium to migrate. So if you take a cross-section of the battery, you can see the molten sodium being formed. So the unique part of the battery, it's a self-forming anode and a self-discharging anode in the battery. Very unique technology. Here you can see the battery discharging. The sodium ions are now migrating it back, grabbing the chloride and becoming salt again. So very interesting technology here. Next slide. So if you compare the battery, it's a very similar energy density to the lithium iron phosphate battery. It's got a very similar energy conversion, but of course the cycle life is nearly double, much safer because we don't have fire issues. And I mentioned it operates in a very large temperature range. The main point in this slide is the maintenance costs. It actually has virtually zero maintenance costs. So in a LFP battery like the Tesla Megapack, there's something like 240 cooling fans trying to keep the battery cool. In our battery, it actually looks after the temperature itself, because when you charge the battery, it is an endothermic reaction. And when you discharge the battery, it's an exothermic reaction. So it monitors the energy. Next slide. Our market is actually the grid storage market. We're not looking at entering the EV market. And the reason for the grid storage market, if you look at this animation, we generally generate power during the day with the solar panels and so on. But what a lot of people don't realize that during the day, Germany discharges about $2 billion worth of renewable energy to the ground. California, something like 3 billion. And the reason for that is there's an excess power during the day. Now, the future of EVs, as more and more EVs come online, they're going to draw a lot of power during the day when they charge up. And so you actually need grid storage batteries. So a grid storage batteries, it's just batteries that sit on the grid. And essentially during the day when the sun's out, they charge these batteries. And at night, they discharge the batteries. And essentially, it's an energy shifting exercise. The next slide. The grid is growing at 28% year on year. And even Elon Musk has said the future of the battery industry, their battery production, will be the grid storage market. Okay, so let's look at one of these batteries being produced in essentially a pilot plant that has been built by the Fraunhofer Institute. We are producing these batteries now as a prototype. Here you can see the alumina being mixed. This forms the ceramic bit of the battery. The alumina plus any extra additives goes through a spray dryer, and these are then sintered in these kilns. So the ceramic piece is the solid state. Once this is formed, it's checked for quality. As you can see, you can pick up any defects by just using light. And here you can see the ceramic piece being assembled in the metal canister. The next part of the process is to add the salt and the nickel metal powder, which forms the internal part of the battery. And then the next step is to then start welding these batteries together. As you can see, the welding process here, and some of these batteries undergoing some tests under different temperature conditions. So our joint venture is, we own 75% of the joint venture. We are building a 100 megawatt battery plant in Saxony, Germany. Next slide. So as you can imagine, we are producing these cells at 1 every 45 seconds from scratch. So you can imagine that there will be a lot of automation and robotics, and Germany is a great country for that. There is a very strong automotive industry with a lot of automation and robotics. Next slide. Our first product is this 60 kilowatt pack, 100 amps, 600 volts, and essentially you can see the cross section of it. There are 5 shelves of these 240 cells. What you notice is that there's no cooling fans on these batteries. They can sit in the snow, and they can sit in the desert, and they can operate very well without any of those cooling fans and so on. These 60 kilowatt batteries will then go into our basic product with this, which is a 1 megawatt battery pack. Next slide. This 1 megawatt battery pack has 18 of these 60 kilowatt packs. The whole idea of it is they can be delivered onto site without installation. You can drop it on the deck. It's a plug and play scenario, and immediately within 5 minutes, you've got 1 megawatt of battery storage connected to your grid. And this is really the key to the grid storage market, where energy is being provided, produced by these solar panels and so on. So essentially, that's our business model.
Thanks, Iggy. Great presentation. Number of questions have come through. Just in relation to the joint venture, I understand. Well, it's understood in relation to the project that's being built in Saxony. Does that cover everything from the joint venture, from the site to the pilot to everything, or is that multiple joint ventures?
No, that's one joint venture. We own now the technology, worldwide technology. We have the exclusive rights, so the patents that Fraunhofer have come under the joint venture. So the future is that we would then look at building gigafactories after this 100 megawatts. So the joint venture owns all the technology. No one has the right to license it without us.
And take us back to the start of the journey. Clearly, I remember even you talking to me about this project many years ago, and at the time it did seem like quite an adventure and something that certainly to aspire to, but well and truly ahead of your time. The question here is when did the journey start, and what triggered the decision for you to focus in this area?
Yeah, so a lot of people have asked why the Fraunhofer Institute have teed up with an Australian company, and we've even asked them that question. Why haven't you teed up with a large German company like Siemens or BASF? And essentially, they said they just take so long to make decisions and to move. We wanted somebody that is entrepreneurial, that had a background in the alumina side, which we have, which is the ceramic bit, and also background in batteries. Our team also came from the lithium battery industry. So essentially, that's how we started. And we recognize that the future of grid storage battery is going to be an area that is nascent at the moment, but potentially lots and lots of growth. And that's the sector we want to be in.
And what was the history of the battery tech? Was it always designed as a tool for grid storage?
Yeah, the technology is actually not new. It's in the 90s, these batteries are being produced for application like buses and so on. So they have been in circulation. So that's why we can say these batteries last beyond 15 years. What the Fraunhofer people did was to scale it up so that it can cater to the grid storage market. So these batteries are about 3 times larger than the 90s technology.
There's some questions here around status on a couple of things, obviously, that shareholders are waiting on. What's the current status of the 2 Seren Energy 60 kilowatt an hour prototype batteries? Are they still being fabricated, or is fabrication complete and now being tested?
Yeah, they're right in the middle of fabrication. So within the next quarter, we will have those prototypes up and running and just going through the tests. It doesn't really slow up what we're doing. We're finishing a definitive feasibility study. So within the next quarter, we will be announcing that. We are already in application for grants. We think that the funding of the project will be threefold, consisting of roughly a third of grants, maybe a third of debt, and so some equity. So we're already talking to various banks around Europe. And we're also looking at the permitting process as well. We want to get that underway. As you know, we've got the land, and really we want to keep pushing all these things. And so the prototype doesn't actually hold it back. The next important milestone is to get an offtake with 1 or 2 parties to purchase all the batteries we're going to make in the next 5 years.
That was partly my next question. Who buys these products, and at what stage are discussions with potential customers?
Yeah, we've got interested customers. We're virtually looking at 1 or 2 to take all the batteries, and they are generally utility suppliers. So they produce electricity, and what they're doing is moving to renewable energy. So a particular one we're talking to are putting something like 8 gigawatts of renewable energy onto their grid, and they need batteries essentially. And they're not concerned about the type of batteries. They will use a combination of batteries, lithium-ion batteries, our batteries, or redox flow batteries. It doesn't really matter, but they need that energy storage so that they can shift the energy during the day to the nighttime.
Some good technical questions here. Is the battery efficiency market competitive?
Yeah, the battery efficiency is very close to lithium iron phosphate batteries. They take about 8 hours to charge during the day, and they can be discharged during the night for 8 hours. The maximum they can be discharged is 4 hours, but also they can be used as a power discharge. So nearly a quarter of the density energy of the battery could be discharged in 15 minutes. So that also is important for frequency modulation in these grid storage.
Do you see these type of batteries potentially reducing in size and overtaking lithium batteries in the future, or lithium-ion batteries? Sorry.
The battery is slightly heavier than the lithium-ion battery, and that's why grid storage is the ideal market. It doesn't, it doesn't matter that it's sitting there on the ground. So it's really the key market. And we didn't really want to compete in the EV sector. The EV sector is generally overcrowded, but we wanted a market that is nascent and has a lot of growth, and we can dominate that market early. And essentially, that's why we're just focusing on grid storage.
And do you have any competitors using similar technology?
No, not similar technology at all. There are other. I think you would see people on the news about sodium-ion batteries. Sodium-ion batteries are actually like lithium-ion batteries, but they're using sodium. That's a totally different chemistry to our batteries. The other type of batteries are sodium-sulfur batteries, which is a Japanese company called NGK. and also as a different type of technology. Our batteries are much safer than the sodium sulfur batteries.
Thanks, Iggy. Great presentation. Clearly generated a lot of interest. And as I said, one of two stocks that was much in demand from viewers of this webinar series to get you on. So we appreciate you coming on and telling the Altech story. Iggy, thanks for your time.
Thank you.
I would now like to introduce Samuel Ekins from Wildcat Resources. Wildcat is focused on unlocking value by way of discovery, targeting world-class provinces across Australia. The team has a successful track record and is focused on exploiting the company's current portfolio of exciting projects. Samuel, I'm just turning you on. Apologies. Over to you.
Thank you, David. Yes, so can you just skip forward to 2 slides? Yeah, so Wildcat is a Western Australian-based exploration company. We've got 3 major assets: the Mount Adria Gold Project in New South Wales, about a 1 million ounce gold deposit, close to 1 million ounces. We've got the Bulk Lithium Project in just south of Port Hedland, and in May this year, we announced we'd entered into a binding agreement to acquire the Tabataba tantalum lithium project, which is also surrounded by our Bulk Cutter project just south of Port Hedland. That's been transformational for Wildcat and is a very significant acquisition. Just to give some context to Tabataba, in 2007, GAM, Global Advanced Metals, the company from whom we're acquiring this project, acquired from Sons of Gwalia 4 significant assets. They were Greenbushes, Pilgangoora, Sons of Gwalia, Wodgina, and Tabataba. The first 3 are obviously major lithium producers today. They started their lives as tantalum producers, and Tabataba, also a significant tantalum deposit, has up until recently never been explored for lithium. And we just recently released assay results from our first phase of drilling. We've demonstrated that there is a significant amount of lithium there and a lot of potential at the project. So we're extremely excited about it, and it's certainly got the makings of potentially a world-class lithium deposit. So Wildcat, at the moment, we've got 665 million shares on issue. After the deal is completed, we'll have just over $1 billion. We have $9 million in the bank, and $7 million of that is in trust, and that will be coming out imminently when the final hurdle for the deal is completed, which is Foreign Investment Board approval, and that should happen anytime in the next week or 2. The company, just as an overview, the people involved, we've got Jeff Elliott as our non-executive chairman. Jeff's the former managing director and one of the founders of CSA Global, which is one of the world's most well-regarded geological consulting groups. I'm a geologist. I've had about 17 years of experience, and Wildcat is my first experience as an executive in a company. Matthew Banks and Alex Hewlett, they put together Spectrum Rare Earths, which became Spectrum Metals, and made the Penny West North discovery. They also founded Red Dirt Metals, which became Delta Lithium. And Matt Banks is also a founder of Rumble Resources, who have made the significant Erahidi discovery in central Western Australia. 2 weeks ago, AJ joined our board. AJ is a very well-regarded mining engineer with a strong track record of success. He's held a number of executive roles in multiple companies, and he was the former mine manager of the giant Grasberg mine. So he brings to the team the mining engineering capability that we need to spearhead this project towards production, assuming we have success over the next few months. Next slide, please. So that diagram there, that photo that you can see there, that's the Tabataba tantalum open pit. They had a go at mining that back in 2014 for only 3 months. They just took out 1 bench. But what you can see in that photo is that it's a particularly large pegmatite body. That is one of 38 outcropping pegmatites that were mapped in the 1980s by Pan Continental, who owned the asset before Sons of Gwalia. And we've subsequently added significantly more of outcropping pegmatite to the area. So now it's quite a significant field. There's over 3.2 kilometres of pegmatite outcrop. Next slide, please. So location, it's where that blue dot is in the middle of that map. It's 80 kilometres by road to the port at Port Hedland, and that's via the Great Northern Highway and Marble Bar Road, and then the Wallarina Station Road, over which we have a miscellaneous haul road licence. It's only 47 kilometres by road to the processing facility at Pilgangora, and only 87 kilometres by road to the processing facility at Wodgina. So it is arguably one of the best located projects in the world probably today. It's surrounded by our bulk cutter project, which is shown in blue. The light blue are tenements that are in application, 100% owned by Wildcat. The dark blue are granted tenements that are 100% owned by Wildcat. And then the grey tenements are applications that are subject to a ballot. So we have a chance of getting those tenements. In total, over 900 square kilometres of tenements with exploration potential surrounding Tabataba. The neighbours to the southwest are De Grey Mining. To the northeast is Fortescue Metals, and surrounding that is Sayona. Can you please move on to the next slide? So this is just zooming in on the Tabataba tantalum field. The blue that you can see outcropping the blue that you can see there are the outcropping pegmatites that were mapped. We commenced drilling in the northern area and then progressed to the central area. In the northern area, we intercepted stacked shallow dipping pegmatites, the largest of which is averaging about 25 to 30 metres wide and running at about 1.1% lithium. In the central area, however, we intercepted a very, very large pegmatite body. The first couple of holes were drilled from west to east and intercepted thicknesses of over 80 metres, and then we drilled a hole TARC 089, which was over 215 metres of pegmatite. At that point, we realised that we may have been drilling down the pegmatite, and we turned the rigs around, and lo and behold, we had been drilling down it. The true thickness, though, at that point was over 53 metres of pegmatite. We then progressed to the north and have had intercepts up to, so far, 135 metres wide, true width. Now, that's just pegmatite. It hasn't been assayed yet. Although that said, the assays received from drilling down the pegmatite did indicate large amounts of lithium, so we're quite confident about that. Currently, the central pegmatite is over 1.2 kilometres long. It's open to the north. It's open at depth. We've drilled it to a max depth at this stage so far of 300 metres down dip. It's very, very big, and it appears to be getting thicker and larger north and at depth. Next slide, please. So this is a section through TARC 089. The section is shown on the map on the left. You can see that the TARC 089 is drilled down the pegmatite. We followed that up with holes 17, 18 and 19 and received very thick intercepts of true width. The assay results are very encouraging, the best intercept being 51 metres, 1.5% lithium from 183 metres going down TARC 089. So some really good lithium results in there, a very, very thick body of pegmatite. And what was also exciting is we also intercepted numerous other pegmatites stacked adjacent to it. So we had, there's a sort of a 10-metre pegmatite in the far east of that section, then a 30-metre pegmatite, the main pegmatite body, and then a pegmatite that's about 15 metres true width just below that. So, overall, a really thick package. That one that we showed in the previous diagram that's coloured in blue is really just that middle thick pegmatite. In terms of what we've drilled to date, we've really only focused on that central pegmatite so far. There's a lot of opportunity to the west of that pegmatite in the outcropping pegmatites that have had very little drilling to date, and to the east of that pegmatite as well. And the western side of it goes under cover, so there's a lot of blue sky. Next section, please. This is another section, just 160 metres to the north of the previous one. The thing that this one's showing is, again, drilling down dip, but also some really good lithium intercepts. But the whole TARC 132 intercepted a true width of pegmatite of over 135 metres, so very, very thick. The next hole's up dip of that, 68 metres and 48 metres, so quite an exciting body, a lot of potential. We're looking forward to those assays. Next slide, please. So mineralogy, the photo on the right shows lots of salmon orange colouring associated with very high-grade lithium results. Those, we believe, are spodumene. We're awaiting quantitative XRD analysis to verify that. But if you do Google spodumene under fluorescent light, it shows it has quite a bright salmon orange fluorescence. So we're quite confident that that is spodumene. The photo on the left is a pegmatite outcrop on the very south of the pegmatite field. And the brown one that says Tabataba is that outcrop. I compared that to an outcrop from Manitoba, Canada, and you can see that they compare very favourably. So we sort of had an inkling that there was spodumene in the system. We've drilled it and we're pretty confident at this stage, but we are awaiting final metallurgical work. We've got 2 drill rigs drilling at the moment, and we're bringing a diamond rig on in about 2 weeks' time. That will help us with the metallurgy and the mineralogy. Next slide, please. That's just a photo from our camp. Top Drill are our drillers, and they've got at this stage a 30-person camp. It's modular and it can be expanded up to 52 people. This is just looking towards the east from the camp. It's nice flat topography and shallow hills, so very favourable from a mining proposition. Next slide, please. This is just to show the Greenfields potential of the project. The pink bodies are the source granites in the district. The grey structures are the shears. Basically, if you're proximal to source granites and shears, then you are in a proximal setting for Greenfields lithium. The tenement package on the west, 5623, abuts one of those granites and is very prospective. It's undercover. There's a tenement called 6155, which is only 10 kilometres to the north of Pilgangoora and has numerous tantalum workings and outcropping pegmatites on it. That's also an exciting target. And then the Bolt Cutter East tenement, which we've announced results about previously, has had over 2,000 soil samples on it to date and has a very, very large lithium anomaly in the centre of it, which is also an exciting target for Greenfields work. Next slide, please. So in summary, we've got a significant land position in what's arguably Australia's #1 lithium province, currently producing over 20% of global lithium supply. There's massive exploration upside at Tabataba. It's over 3.2 kilometres of outcropping pegmatites, and we've only just started to scratch the surface. The one main pegmatite in the centre is over 1.2 kilometres long and very thick. It's hosted on mining leases, so they're mining tenements, which means it's a very short time between discovery and production. We've got 2 RC rigs on site at the moment, a diamond rig coming on site, and we've got 2,000 holes approved. It's fully cleared for heritage, and we've got excellent potential in our regional ground for Greenfields lithium. And that's it. Thank you very much.
Thanks, Samuel. I suppose this is a $500 million question, not $1 million question. How did you actually get the project? And just to reiterate, what are the key terms?
Right. Yeah. So it was
I suppose looking back, how does a project like this sit, in some respects vacant or idle, to be picked up by a junior such as Wildcat?
Yeah, it's a very long story, and it's probably not a simply answered question. It was a 9-month process, and there are a variety of reasons why Tabataba sat idle in GAM. GAM had divested other assets. The 3 major ones: Greenbushes, Pilgangoora, and Wodgina previously. This one has just been sitting there. I think previously it was just considered to be a tantalum project. They're a private company. It was a lot of work from our directors to make the right relationships to get the deal in process. So really, there's a lot of moving parts that were there in place to get it to happen. Suffice to say, we were very fortunate and able to do the deal.
Was it competitive to get the project, given what everything around the project itself tells you this has the potential to be a significant lithium project, as you're uncovering now? Was it competitive in the sense that a lot of people were looking at it, trying to get it?
We believe so. We believe that some of the majors were trying to pick it up. I suppose the key thing was that Wildcat offered GAM 15% of Wildcat. That enabled them to share on the upside should we have success. So there was 186 million shares that were issued to GAM. and that's probably a big part of the story. Wildcat also has a gold project, which is very appealing. We've got the very strong land holding in the district, and we demonstrated that we had the technical team to be able to drill the project. So there were a lot of sort of factors that we presented that I think gave them confidence that we were the right team to use. Whereas an outright sale, I don't think they would have necessarily got the value with the upside.
Is the plan here just to drill, or is there a dual strategy of drill a certain amount to get a resource or potentially to then move into a study phase? Or is there just a lot of drilling that needs to be done to build up and really understand what you've got here?
Yeah, so we've got a dual strategy. It's got existing mining tenements, so we want to refresh those tenements as quickly as possible for permitting. So there has been disturbance previously, so we need to get the previously disturbed areas refreshed. We need to commence foundational studies such as fauna, flora, hydrology, and things like that immediately. We've commenced that process, and AJ is assisting us with that. So the sort of the progressing towards mining as quickly as possible process, and then there's also the drilling and verifying the resource as quickly as possible process. We've been drilling since July. We've drilled over 87 holes for 15,000 meters so far. We're not going to stop drilling. We're going to add additional rigs. We've got a diamond rig coming next week. We'll bring another diamond rig on soon. We'll be drilling until we've got a resource. Really, at this stage, we're still trying to understand the limits of the main central pegmatite, and then we need to understand the limits of the other pegmatites before we are in a position to start putting resource numbers together. But that is something we are aiming at doing as quickly as possible.
In terms of targets, good question here. With the diamond rig, is that an infill or a step out style program, or a mixture of both?
It's a mixture of both. So we'll be stepping out, testing at depth, testing along strike, infilling for metallurgy, and for to understand the difference between the assay results in RC and the diamond. Typically, you see a downgrading in the RC, and when you drill it with diamond, you get a bit of an upgrade because you lose a lot of the spodumene as dust, apparently. But we need to verify that. So there'll be those sorts of studies going on. Really understanding the mineralogy. A lot of diamond drilling to be done to follow up now.
WA is a very, very hot sector area, if you like, for lithium. We're seeing, billionaires joining registers. We're seeing majors investing in lithium companies off the back of rock chip samples. How do you protect value? How do you actually make sure that you're protecting and enhancing value for shareholders as much as possible in case some of those things happen down the track?
Yeah, so speed is one. We want to get a resource to grow as quickly as possible. We want to move down that road towards production as fast as we can. So the faster we move down that road, the greater the premium there. So that's the first step. We are looking at our takeover defence. We've got basically mostly retail investor base. GAM will have a 15% stake in the company, and they're a major supporter. So that will help us. They can earn an additional 5% with the announcement of 10 million tonnes at greater than 1% lithium. So that will assist us to maintain that. We've got a very strong relationship with our existing shareholder base. We had in our EGM to announce the deal, we had over 50% of the register voting for the EGM. So we have a lot of support, and really for us, it's really maintaining that support, keeping people on board, and making sure that we've got the strength to be able to withstand any kind of takeovers like that.
How busy was the phone when you announced the deal? Did you
extremely busy?
Peak some interest?
Yeah, very much so, and it's still ringing off the hook.
It's always good to be loved. Now, there has been some chat about the company drilling what's known as director's holes. So trying to put a hole down where you're confident you're going to get results. How do you respond to those sort of comments?
Look, it doesn't need too much response. We were very clear in the announcement that we had drilled down the pegmatite, and that wasn't done on purpose. We had our geologists in the field, had done a lot of mapping work. There was very clear magmatic layering in the pegmatites, and they really did look like they were dipping to the west. We drilled the first few holes into that, and that, it's RC, so it looked like it was true width. And then when we hit the really big one, we sort of got, it can't be right, and so we turned the rig around immediately. But we clearly articulated that in the announcement. We showed it on the first section. That's why we put sections in there, so we were very transparent about that.
How much do you watch your peers in the lithium space in WA in terms of their results, the way they're tackling mineralogy? Do you watch what others are doing to see if there are lessons that can be learned, and probably vice versa?
Yeah, very much so. Yeah, no, we definitely look at what the other neighbours are doing, people like Azure and Liontown and things like that.
Where to from here? So it's all about drilling. How far does the money run to get you through this drilling program, and what's the next value proposition? Is that the drilling to a resource, or is it building out more understanding of the pegmatites, mixture of?
Yeah, look, we're burn rate at the moment is about $1 million a month. We've got 9 in the bank. When the second rig comes on board, it'll be about $1.5 million. So we've got enough cash to last us well over 6 months. The objective at the moment really is to just drill it as much as we can, understand the scale, and then begin infill drilling. So I suppose the next steps are really we're going to have a lot of news flow. We've got 60 odd holes at the lab at the moment. We're expecting assay results every 2 to 3 weeks, and to be announced as we progress. So there should be lots of encouragement from that. And really the where to from here is hopefully defining a very large system that's got a lot of scale and a lot of good good assay results. Thanks,
Samuel. A world-class project potentially emerging here in Western Australia, a company to watch, a project to watch, strong news flow. We can't wait to continue to watch the evolution of Wildcat. Thanks for your time.
Thank you very much, David.
As I said at the beginning, the purpose of these webinars are to get on companies that are on your watch list, or companies that you want to put on your watch list to potentially watch. These 2 companies are just that. You guys have been asking for both of these companies for some time, so we delivered. Make sure if you have any other companies on your watch list that you do want to see or hear from, or companies you're looking to invest in, to contact Stuart Walters at Market Open on the email address below or on the screen, and he will take care of that for you. Thanks everyone for taking the time. Thanks to our presenters, and we will see you again in a few weeks' time.